Here's to the builders, the installers and the specifiers, the people behind our homes, creating plans, foundations, frames and walls to build homes filled with love, laughter, tears and joy. You're architects of innovation, designers of comfort, builders of dreams and installers of perfection. With skill and determination, you're building a better New Zealand, and we're here to support you every step of the way. Jib, let's build.
E nā mana, e nā reo, e Ngāti Whātua, nā kaitiaki o whenua nei, ka nui te mihi. Ka mihi hoki, waipapa taumatarau, e whakakōtahi, mei nei a ia tātou, i raro e te maru o te toi, me te whakaro nui. He mihi nui hoki kia windstone wallboards, jib, mō tō rātou tautoko e tēnei kaupapa. He mihi nui hoki kia te kāhui whaihanga New Zealand Institute of Auckland's Auckland branch, Tāmaki Makaurau me titai tōkaro kia tēnā koutou katoa. When in 2021 I was asked by Architecture New Zealand to reflect on a 30-year absence from Aotearoa, I wrote an article called Transcolonisation, 1990 to 2020. It traced 30 years of the slow road to Te Ao Māori architecture and the quest for the emergent architecture to reconcile colonial traditions and European influences with a sustained interest in the Indigenous project. Thanks to Tumu Deirdre Brown's prompting, Transcolonisation then turned into a fast-forward archi lecture series with a whakapapa back to 2021. The 5 speakers back then included Tim Melville, the only independent Māori gallerist, and Nigel Burrell, curator of Tūhoe to Ora, the largest exhibition of contemporary Māori art ever staged in Aotearoa. Nigel controversially resigned on the day the show opened. Our second guest was our first Māori law professor, Jacinta Rudu, who spoke of how in a world first, Māori values of taeao and kaitiaki gave rise to legal personhood afforded to the Te Uruwera and Whanganui River. So what does legal personhood mean? It's granting to a natural landscape feature as being a legal entity with its own rights, similar to how the law recognises corporations, trusts or charities as people. So perhaps one day an ancestral house, the whare tipuna, might also be afforded legal personality. The third talker was the Māori novelist Witi Ihimaera, who had just published Navigating the Stars. Sadly, back in 2021, this was the only talk in that series to be kanohi, ki te kanohi, as COVID meant the other talks were all held online. So to overcompensate for that talk, we invited the Sound of Pacific. If Flying Nun was out of Samoa, you might have a Samoan Māori indie jazz band called Leo to play. And as I said last time, probably not so funny this time, it was probably the only time you're going to see a Moog synthesizer on a lectern. Some of you may be back here again tonight in that photo. Melanie, Denise, Matt up there. But poignantly, as I said last time, at the top of this is our Managing Director, MD Michael Davis. And of interest is the whakapapa that you two have for graduating in the same year here at this university. Furthermore, there's also a shared whakapapa you two have, so the bromance is large, to the Architecture Association in London. We both studied and graduated a year apart. It's a lot of shared love. In the photo you can see our MD standing directly behind Zaha, circled in the front row. And as we saw in the previous photo, Mike has a killer instinct for strategically positioning himself in relationship to people and place, which makes him a great head of our school. The fourth speaker in the previous series of transcolonisation was Paul Majuri, rangatira of the Tipuna Monga Authority, in a demonstration of kaitiaki for Tūhoe. Under Paul's watch, the authority rid the city's tallest volcanic cone of cars and replaced it with a boardwalk designed by Isthmus. Michael Thompson, don't know if he here, tells me of stories of bikers that used to motocross around the crater. So today it's Wāhi Tapu, a sacred place of immense historical, cultural and spiritual significance, thanks to Māori values in the built environment. So, and finally our last speaker, last time was a filmmaker Chelsea Winstanley. She's offered to maintain the connection to this talk by also being the final speaker. And maybe you recall a few minutes ago I mentioned Nigel Burrell's resignation from the curatorship of Toi Tu Toi Ora. Well, Chelsea made the documentary Toi Tu Visual Sovereignty, which charts Nigel's curation and resignation, and it screened last month at the Berlin Biennale. So, you wait all your life for a Māori professor of architecture, and suddenly two professors turn up at once, greying and brown and bearded. I first met Derek in 2002 back in London when he was studying for a Master's in Design Research and Urbanism at the hallowed Architecture Association under Patrick Schumacher's tutelage. Some of you might know of Patrick as being the head of Zaha Architects today. In a 2023 review of the Whakaata Māori television series Drawing Board for Architecture New Zealand, for which Derek presented, Auntie Matilda, I think she's up there somewhere, and I wrote, Kawiti is an AA-trained professor of architecture specialising in contemporary manufacturing technologies and automation. This reveal alone would have jettisoned the arts and crafts nostalgia of the drawing board in favour of an emergent Indigenous digital computational space. I commented that sadly in the series, our host remained enigmatic. Well, not tonight. E tēnei pō e te rangatira, e Derek Kawiti, no mai, haere mai, ki wāinga nui I mātou. Indigenous thought leader Derek, welcome amongst us here at this school named by Riri Thompson as Te Pare, the lintel. He manuhiri rangatia koe, nā reira, kia whakatau atu mātou ia koe me te nāko mai aha. Our distinguished guests, we receive you with warmth and respect, and a kāri dinner at Prego afterwards. Kia ora, Derek.
Kia hopu ake au ki te toki matanui tā whiorangi ko te kuharere mai te maramara tupu whai ake, nō raro hakahotu nuku, hakahoturangi te manawa. Tēnā tātou. Tēnā tātou e te hunga haka eke mai nei I tēnei yahi pō, ki tēnei tō tātou taumata ko te pare. Tēnei te mihi mai kia hau. Ko tatu nei. Haere mai ki taku kōrero whiriwhiri whakaaro I tēnei pō. I raro i ngā manaakitanga o rehua I te rangi, I raro I ngā āhuatanga o ngā huru hangarua. Haere mai koutou. Haere mai me ngā kōrero, me ngā here kōrero o te wā tātou ki a tātou. Ko ngā kōrero tuku iho mai e ngā tupuna mātua a kia mātou I tēnei wā. Tēnei te mihi atu kia tātou. E kore mātou e ware ia rātou ngā mate tuatini takoto mai ai I runga I ngā marae maha, I runga I ngā papakainga, I roto tonu I ngā whare putanua. Ko uhia ki ngā taumata kōrero e tika ana. E pērā tū ki te wā I taka ko te tahi o ngā mokopuna, ko te tahi o ngā tamariki o te kāhui whaihanga nei a pip Cheshire. Tēnei te kupu poroaki ki aia, te mihi ki aia, e te rangatira e moi o ki atura. Me ki pēnei ake te kōrero tuku a rātou, kia haere tuku a rātou kia oki i runga i te moingaroa. Apiti hono, tātai hono, ko te akaaka o te rangi kia rātou. Apiti hono, tātai hono, ko te akaaka o te whenua kia tātou katoa ngā waihotanga iho nō reira tēnā rā tātou. Mihi atu e tautoko atu i ngā mihi ki te haukainga, ki te o Ngāti Whātua, me te tine atu o nehe o nei tonu. Nō konei tonu au, i taku nei toto i te kaipara, heki ho mai a mate kai rangatira, me ona kāhui reira Ngāti Rango, me te tine atu Ngāti Hine e noho tonu atu, haka māhana tonu atu te papa i reira ki puatahi. Mai taua tūnga, mihi atu ki te mata, ki te waite mata. Kahuri au naini, kia mātou anō, tēnā rā tātou katoa. I'll take a breath. Hopefully the presentation's working. I had some glitches earlier. But welcome to my talk, everyone. It's always an odd position when you're not quite mana whenua, but you are to, in some respects, to structure your mihi. But welcome to you all today to my talk. Thank you, Professor Hoete, for your very generous and really modest, understated introduction. And I'm never entirely sure of some of the things that have been said that I've done or some of the things that are yet to come, but as an architectural practitioner, a designer, an academic, I'm sure you can all relate. It's a bit of both, really. And so thank you again for coming. For those that may not know, and Professor Hoete alluded to my involvement with the school, some 12 years ago, I was here as a lecturer. I was actually fresh out of London big practice, big ego practice. And I was appointed by Mike and a few others to take charge of the, I think it was multi-story construction paper, which I've tried to banish from my memory. But I was also unofficially contributing to the digital culture of the school at the time, especially through some of the great initiatives that we had going at the time, which I would argue was the peak of digital usage and adoption of digital tools by any educational institution. I ran papers like Pluriform and Dynamic Forces and others that were trying to lift students into the space, to get them excited about what the future could hold through the adoption of digital tools. So I was quite happy to do that. I got employed to run workshops and so forth. But I have to say that 12 years ago, we didn't quite have the tools that we have available to us now. And the students are they're quite remiss when they run into problems to not work things out themselves, as we had to, through some of the implicit and explicit ways of dealing with computation and computers, generative design and software. Some 12 years before that, I was here. I went to the AA, and I was there with Mike with an overlap. But 12 years prior to that, I was a student. Prior to my last stint as a lecturer here, 12 years prior, I was a student here in a school that was very much burdened by modernism, very much still in the dying throes of modernist doctrine, through mainly our design studios, which was activated through rigour and through highly disciplined drawing traditions that the school had mastered over the years. So I was looking back, I'm quite honoured to be part of that, but there have been changes that just through my shift in focus, but also when I was looking back to when I was a child, and my use of computers and that sort of thing wasn't quite normal, I have to say. for a practitioner and academic of my age. And so it's like going home. For me, there's much comfort in that way of working. Looking back on this time in the school, these were my mentors, actually. And although we had, we had these very rigorous design studios, we had the main culture of the school was something separate to the legacy of my or our tupuna. And so it was, for me, my mentors who were some of the first designers, the first architects, the first people that shaped Aotearoa through design, through policy, through fighting and war, through public opinion, through lobbying their people, through fighting for their people, and critically through their adoption of technology. And just quickly, I also worked at Noel Lane Architects after graduating for some 3 years. I worked at Unitec for a year or so before going to the UK, at which point I worked for, after graduating from the AA, worked for quite a few large-scale architectural practices, moving around a lot, contracting a lot, mainly learning the way that they would undertake jobs, learning their workflows and file systems. Inevitably, I got dragged into a lot of digital work in those contexts as well. So this is just some of our AA work we're doing at the time, social systems. This is John McCaslin Architects. I worked directly on the St Pancras, the large forecourt canopy. A lot of the guttering systems actually between the old building and the new canopy. But for a while there in the office, I was the only one working on the project with some of the cladding specialists that we used to fly in. So I had a lot of good experience over there. Coming back, for the last few years since starting at Vic, I've been running the advanced digital design culture in the school and setting up courses and workshops and so forth. We in the crowd has been a recipient of some of my teaching and playing around with digital tools and trying to understand their complexity and, more importantly, how they would relate to and be relevant to some of our practices moving into the future. So when Anthony invited me to give this talk, probably around about 3 weeks ago, and this is a type of disclaimer, my colleague Tyler Harlan and I were only 3 weeks deep into setting up the new robotics program at Vic. In those 3 weeks and the subsequent 3 weeks after that to where we are today, we've been working every spare moment to bolster the course and to redesign the course from its original legacy. And it was a legacy where the massive firepower of robotics and fixed mechanical machines that I'll talk about soon were being overlooked as viable future pathways for students of architecture and design to scaffold their work into industry and their skills base. So the schools offered the course since 2017 through to 2020, and then there was a lockdown period, which was really interesting to see the course still run because a lot of the robotics work needs to be done on site through working constantly hands-on in a hands-on way with materials, with a lot of the tooling that we have. And so a lot of the courses developed very, very slowly as a result. So we've been charged to bring it up, and I guess that's part of the reason why I'm here tonight, and part of the reason why I did provoke Professor Hoete with the provocation of Indigenous robotics, which you're all very curious to see tonight. But since we've rebooted the course and redesigned it, it's a 3rd and 4th year program. We have 10 or so students we're looking to double. We're looking to double the fleet of our robotics. And we're looking to move more into our PhD programs with a dedicated robotics offering. We also have a large of masters moving through into that as well. So it's really very pertinent that we're ready to serve that growing interest that we have. Those of you who have been to Victoria might know that we're lavish with some of the latest equipment. We're absolutely spoiled in terms of the technology that we have in all of our studios. But coming into the course, and just an observation, and just to start my talk off and to give you a bit of context, we're up against it in terms of trying to catch up on one hand. That's the main task of what we've been doing for the last 6 weeks, trying to catch up to the latest practices in order to then springboard into where we want to go. So Indigenous robotics. Indigenous robotics in the context of this talk tonight will be a very different offering as to what you might have assumed that you will see tonight, but you will see some what I think is exciting work. Some of the work has been accumulated over the last 10 to 12 years with master's students. Some of it's been accumulated through informal interactions with iwi and formal interaction with iwi and using technology in those contexts. So I will take you through as we move through the talk. Of course, we are constantly looking at ways of bolstering our knowledge in order to serve this new cohort of students coming through. A lot of the work that we've been doing over the last 6 weeks has looked at structuring the course to take them right through from the very early stages of using CNC, unsupervised, right through to using clay and sand casting, using PLA casting and 3D printing, using a myriad of ways of making and shaping and fabricating objects. It's not playing, but it's just a milling tool on a piece of gold foam. And so immediately we're interested in the difference between milling a piece vertically, i.e. standing up, versus lying down, and all the different dynamics and all the different workings of the mechanism of the robot in that respect. And so this is our working environment generally, where we try to break down the distance between the computer and the lab and the robots. The last thing we want is students some 30, 40 meters away, disengaged and in studios while they're running their robotics program or running files down to the robot. So we're starting them off on really, really simple projects, but we're moving them through into casting of various materials, through to 3D clay printing, and through to CNC milling and digital carving as well. And so this is one of our current offices, and we're moving into a larger space in the next few weeks. One of the things I will talk about just briefly before we go into looking at some of the work that kind of influences this shift into bringing forward the indigenous influences into digital design and computation, is looking at how, as a Māori practitioner, the difficulty in being able to move laterally from running courses such as Māori-designed environments and those of a cultural nature to a very hardcore technical role in the school where I run the robotics for the entire program, and for industry as well. Some of the offerings will be, but I thought I would say that to support the kaupapa of Fast Forward, just to say that it's a type of softening of boundaries, and that we as Māori staff and architects are always, and teachers are always pigeonholed or boxed into a certain area, a certain cultural domain in particular. And so it's really talking, maybe some of the questions later we can talk about how, on what terms that happens, why does it happen where you can move out of those very fixed and rigid domains into spheres of robotics and digital computational design. So, like I said, there'll be some material that some of you in the room would have seen probably a long time ago. But when I started at the school, I started up a lab called Situa, so Site of Indigenous Technologies Understanding Alliance. A bit of a mouthful of an acronym, but it's based on ancient Greek around being on site and being out of places like behind desks and design studios and being within a material domain of sorts. So this situ was set up, I think in 2014, late 2014, and it was spearheaded by a young master's student at the time, James Durkin. We had discussed and ad nauseum around how it could work, how we could embed this new research intersection within iwi, but then that we would somehow bring all of our technology and enable it to shift and be redefined within that new context. But we also knew that once we got out of the university, there would be some relaxation of or a foregoing of trust in terms of what we're doing, being in someone else's domain, being on someone else's marae, being in someone else's rohe takiwa, and undertaking our work. The aim of Situa was to, on the one hand, as I mentioned, to get students out from behind their desks and into communities, but also allow our technologies to be changed and recoded through that interaction. And one of our first partners was Ngāi Tāmanuhiri from the Gisborne area. We immediately sort of struck up an agreement that we would set up a kind of like an off-site lab that was fully Indigenous in I guess in its undertones and influences, but we were wanting to base it on some of the original work that was coming out of Europe, like Hook Park out of the AA and Grimsdyke Farm. And what we noticed about these two models was that they either undertook work from their schools, or they undertook work from people coming into those places. While they produced some amazing work, especially Hook Park did at the time, it was based in Dorset. It was based in Dorset. If I can remember, it's now sort of, it's waning a bit, but it had students and it had people engaged in AA projects out in the wilderness, out in these different material places. So we based our lab on just bits and pieces of these models that we're already aware of. I ran another course, Corporate Spheres, which was looking at how corporate space could be different for Māori, especially in light of 1995, 1996 with settlement, and looking at how Māori shifted into default corporate spaces for undertaking their work. So they were basically moving into corporate buildings or leasing space without any design influences incorporated from any cultural influences incorporated in those designs, and creating office environments for their workers to set up to start growing their businesses. So at the time, also this is another project, another lab that over time it just sort of it loses its bite in terms of how students are interacting with it. But we're trying to teach students about the Māori economy, and what the Māori economy means in terms of behavioural patterns and what it means to be a Māori employer or a small medium enterprise that's Māori, and how your behaviour is conducted differently commercially, your investment models and everything. And also your approach to space, how that might shift and change to be more calibrated, more aligned with what you do. I also ran a Tūhoe summer school. I don't think there's anyone here that was on the Tūhoe summer school, and I'm just taking you through some of the labs that I've run and set up and summer school workshops as well. But we did this one with the University of Melbourne. I'm not sure whether I can fast forward this a bit. How do I do that? If I play it, it's some 5 to 10 minutes long. I will. Oh, here we go. So we're based in the Te Urewera. And Te Urewera, and we were given a whole portion of the river to start looking at mosses, to start looking at soils and clays and stones and rocks, and starting to do material research using a very basic tool, a brick maker, but we were digging holes and casting and doing all sorts of different materials research with year 2 and year 3 students. And we were there for 2 weeks where we worked with Tūhoe, we were with Tamati Kruger and Kirsty Luke and co, who are really welcoming of our approach. And I whakapapa to Tūhoe as well, but we just really teaching the students to unhook and to get out of design studio environment and be productive, be hands-on. There is a bit of a jingle that goes with it, but actually it's better with the music. But people would turn up and give us different materials to work with. And so it was great. It was fully interactive. I mean, they did some the students also had a great, let's see if I can get further along, a great time. We kiln fired. We did a lot of found clays. We actually worked with some pigs that were in the adjoining field. They had mixed up a whole a puddle of amazing mud that was so incredibly fine, and so we were doing some 3D printing as well with clays. And so here's some of the other extracurricular activities that they were doing as well, exploring the riverbed and stuff. And so this is continuing on with Situa. This is some of the early work that we did around papakainga. So we looked at computationally understanding what papakainga could be through a digital system or a digital model. We actually used some really basic scripting and coding tools and processing, and we tried to get our heads around the different variables and criteria for what we were wanting to have, like an urban papakainga. So we have the different statuses of settlement and habitation of a place, mana whenua, mātāwaka, taurehere, etc., etc. And we looked at how using a really basic swarm algorithm, how we could create clusters and settlements and alignments and repulsions and those sorts of things that are found in nature. We looked at tribal groupings. We also looked at house type, view, and a whole lot of other things as well. So this was some of the research where we were trying to bring Indigenous thinking or Indigenous ways of upsetting the tools that we had at our disposal. So worked on that with Ariana Ballantyne and Catherine Campbell-Hunt. And so we had some really interesting results in the end. And just one of the thesis projects that students produced down there, very technically focused in comparison to what Auckland was doing at the time. Landing there was it was very much an upward curve of happiness for myself anyway, just in terms of my pragmatic bent. But we started to look at how Māori had these ideas around tooling and around non-organic or non-human or animal machine partners, collaborators, tooling in a way, jaws that eat things. And we also looked at the idea of whakairo, to hollow out and to subtract material away from a surface. So we looked at the pūriri moth. We looked at how that it hollowed out the pith of the pūriri tree, and how it was back in the day. It was very much coveted for this basic role that it did. And so this is really what started us off opening our research up. We built a double extruder. So we through trying to understand how the natural organic toolpaths of animals, we looked at how that might help us to solve a really high-end problem at the time, which was a low viscous material and high slumping in 3D printing. We built a double auger 3D printer. Through one nozzle we had viscous clay, and then the other nozzle we had an organic material. And because we could use digital tools, we knew that we could create toolpaths to attract vermin or bugs or whewhe or caterpillars into these big blocks of printed matter that we did, and allowing them to excavate, subtract, eat away at the material, and to enable us to control drying, which at the time was quite difficult, and that's with clay printing especially because it was so underdeveloped. That's 2018. And so our idea was that we would place sugars down, cellulose, kai, for these whewhe to excavate and to whakairo away. And we did a lot of simulations, and that was done with Noah Orr and Mark Bagley. We looked at their gestational aspects. We tried to find the ultimate toolpath machine animal to help us to excavate. And then we had to find matching kai, food, for it to help us to excavate away from the clay, the high filigree clay print. I put the sculpture that I worked on as an example, but this is how the principle works. That because you've got a high filigree, this is extremely high filigree object, it gets encased through the double extrusion, and then we allow the outer casing to be excavated away by our toolpath collaborators. And so that was quite a nice project to do at master's level and undergraduate level as well. Again with Situa and with Itia, which is Indigenous Technologies and Architecture. We started looking at a more of a reverse angle forensics understanding of some of the things that our tupuna did in order to fully understand the procedural or the technical modulation of the building systems such as hakari and their various shapes and forms, and in particular this one from the Bay of Islands on the left. We looked at modelling it. We looked at finding what its modulus would be, which is a 1.6. It's called a takoto. A takoto is when you lie down and you put your arms by your side. There are others as well, going from your fingernail to knuckle to wrist to elbow, and those sorts of ergonomic modulations that were specific to how tools and gestures and modular structures worked. So here's some of the, it's kind of like, it's just a backdrop to what I'm saying, but they were quite important projects to help us to open up the spectrum and not close it down in terms of how we wanted to explore Māori technologies. Not so much robotics, because a lot of the machines and a lot of the methods that we started to build were not free, open manipulator machines like robots. They were fixed, and they had a fixed function like traditional Industry 2, Industry 3, 3.0, where they still rely on very much linear actions and types of authorship. So we did the whole shebang where we started to open up this modulation and modulation. We had Lemmy and we had Tamaiti, and we had many other collaborators who were helping us to actually open up the spectrum of our thinking as well around what hakari could be. And we all know Lemmy Bonifacio and Tamaiti. They were sort of saying, well, what if, what does this thing become in the context of today? So one of my master's students looked at populating it into Christchurch. This is another project by another master's student of mine, and when we work in the lab, we work really open and collaboratively. So this was I'm showing you the final image from his project, but what we're looking at was how do we create a subterranean structure that's been injected and then excavated? So we're interested in this idea of atua and matangaro, and this idea of a Māori physics. And so the ground was part of our collaborator that would offer up ground pressures and the general sort of the different compactions and different environment and for our projects to start to emerge from. So this was actually the end game, but I'm putting it up because it best explains what we were trying to do with this project. We were trying to use high pressure ground grouting to create subterranean structures that could then be used in a multitude of ways, either and we did this with Ngāti Tūhoe at Oho in Kawiti. And they had a problem. They said, look, this has been going on for some 60 years, the erosion of the estuary edges. And so they were wanting us to look at how we might do high-pressure ground grouting injections into those estuaries, but allow them to become obsolete and break down over time and not leave concrete structures. So basically creating a type of root system, much like a tree, but looking how the ground might inform its configuration in terms of paths of least resistance. And so we started to work with this idea and this concept, but also we started to work with a simulation, a front-end simulation approach, where we looked at having preset root systems or preset structures that we would inject into the ground via tubes and then pultrude and extrude materials through a structural sock. And we did this in some of our test beds and in some sand environments. You'll see some of the early simulations that we did. You know, students really enjoy this when they start to sort of move it beyond a gratuitous kind of understanding of its, of its conceptual alignments, especially in relation to a project. And so we did early, actually this might be quite loud. We did some early like formal studies and we started to get our heads around how would it be to inject these structures, to fortify, to inject minerals, to revitalize while dealing with erosion. So using a very natural configuration of a root system, but steer it into really volatile environments like beach and sand edges. And it goes on. So this is just some of the early analysis. Tyler is my colleague in our small lab, Itia, at the moment. And we're working like crazy to get everything up and running so we can start moving our thinking into the utilization of this new robotic plane of consciousness, for want of a really cool word. I really want to get and try to get students out of the lab as much as I can. I didn't have the pleasure of having Wirangi as a master's student, but everybody has to get out and get their hands dirty, but also break down the barriers between the actual and the virtual. So we had what was called soft forming and hard forming. You can imagine what they might have been. This is soft forming when you've got a controlled container of sand. Hard forming is when you inject straight in using various grout injection materials. I've got a lot to get through, so I'll just keep pumping it along, but just some of the early studies that we did. So using the ground as a formwork, basically, but also having an interaction with it in terms of creating, ordered exercises or approaches to configuring structure. So we know it will have a structural kind of configuration or diagrammatic kind of function, arches and those sorts of things, triangulation. So we do use preset patterns, but we're still injecting and allowing the ground to mold and shape. This is the one I was talking about earlier. This was our very first project. James Durkin, you might have heard a lot about James. We went into Gisborne, we went into Ngāti. They had 65 of the most high quality clays. There was a geological study done in the 50s and 60s where they found many clays, from cosmetic clays to bentonite structural clays, waterproofing clays. They pretty much have most of the category and catalogue of clays, but there are some that are definitely endemic. So through our interaction with Ngāti Manuhiri and through our making of a delta printer and a one that was demountable as well, you could put it on a donkey and take it anywhere. Through our interaction, whānau there started to comment that they had forgotten how much they had actually used clays in their traditions, cooking food, wrapping a tuna, an eel and then putting that on the fire and firing it, and then peeling off the outer skin of clay or a wood pigeon. The feathers would come off, cook in its own juices, that sort of thing, but also cosmetic clays. We can't say, we managed to reboot a tradition. They were already there, but there was some intergenerational amnesia around a lot of both the materials, and the ways of treating those materials that was really amazing to see, and the depth of it, and the uses, the everyday use of it. There is a, so again I will. So those of you who've seen this already, I apologise, but it is a good watch because it describes the whole process from collecting the clay to drying it, crushing it. It takes about 3 to 4 days to get basically fine commercial pottery clay, and so it's a lot of it has impurities that you remove during this particular stage. This was all done off-site. This was all done in Ngāti Manuhiri, and in front of lots of eager school kids, local school kids. The actual printer in this first printer prototype, which was done 2015, super rudimentary. That was made out of a PVC drum, and then like all the motherboards and everything was built from scratch. A lot of the fabrication diagrams for the actual machine were offline. Were online, sorry, that we built up. And so this was our very first extrusion through a Delta tripod printer. Very low resolution, but we got it to work. There was something like 70% of the printer was printed by our up boxes in the lab. And then as soon as we got to a point where we could confidently start to print, and this was quite some time ago, some 10 years ago, we took it to Ngāti Manuhiri. Actually, these are Wirangi's relations. And so very, the communities, we didn't take the idea that we would ride in on our white horse and save everybody the printer. It was more about allowing the interaction to change our practice, change the way we were sort of framing our problems and whether they were in fact problems, and then trying to then use that to improve what we did or make it more relevant. So we had this idea that we would print a very large structure, but this was the end of a master's project that we were unable to do in the end. And here's some of the raku. We just did basic raku pit firing over 2-3 days. Anyone can do it. It's like a hangi, but you put everything at the bottom once it's dried, and all the timber, all the glazed material that you put in burns down to it and slowly heats it up. We did the same thing in Tūhoe. So you'll see these things come out from our very first print 10 years ago, 11 years ago. It wasn't a bad effort. But it was just because we were just learning on the fly, and we had to move really quickly in order to make sure that our machines worked before we went back into Ngāti Manuhiri. And so here's the setup at Ngāti Manuhiri eventually that we had. And in hindsight, we did a lot of work with the local kids around what they saw when they looked at it. We had a lot of kaumātua come in and say, we wouldn't do it that way, and stuff like that, because we did have glitches in our power sources. And the kaumātua came in and said, what I would do is set up a damper and an elevated drum and all of this sort of thing. So there was a lot of interaction that enabled us to move our tools and our machines. This is another project that we're currently working on, actually, is how to orchestrate magnetic clays or magnetic fluid, cold fluid, cements into non-orthogonal shapes and forms. So either through electromagnets and through reinforcing steels as conduits for shaping those forces. But again, it is about matangaro. It's about understanding the role that energy has to play and what it wants to be, in a way as simple as that. And it is a cliche, but we try to exploit things to enable us to open up the way that we make things for the architectural industry. But a lot of the projects, we've got them running concurrently, and we've got them running in such a way that as soon as they start becoming useful, the student leaves, or they get to the end of the tenure. And that's because the pipeline through to my master's programs are a traditional pipeline. You know, you have NZIA schedule of works or whatever. You have you have the different phases of a project from initial conceptual design and so forth. We're working with architects with that kind of that learning, and then we're trying to bring them back to opening up the conceptual spectrum, as well as try to leapfrog processes in order to build and materialise things. This is quite a good project, and it was done by myself, Angus Horn, where we first started using the robot to clay 3D print. And if you go to Ngāwhā Hot Pools, you'll see the po that's up there now. We worked with master carver Alan Wihungi, Bernard Makuare and others. Very, very special place. It's an area where that was important to all of Ngāpuhi. And so our new building that we put there on site, which I hope you all get to visit at some point, because it was so hard fought for. It was 6 years in resource consent, and then some 4 years getting it built. And then we ran into sinkholes and all sorts of stuff. But those were fully fired, so we took them up to the big clay Knight and Wilson, or Wilson, I get the name wrong, but they put it in their big shipping container kiln to fire it. So I was up there for a week just drying and glazing and those sorts of things. The whānau were really upset and disturbed by some of the versions of po that we had, and we turned up with our van, and we were pretty happy with ourselves, and they're like, no, and being Ngāpuhi, they just go, no, no. And so we managed to get one built, and we'd use a lot of shelf angles for supports, and they're very heavy, but it'll, terracotta will last some 200 to 300, 400 years easily. And here's some of the other ones that were rejected. That one rejected vehemently, really loudly, by everybody. Said it would look like an alien, but it was a problem with the tools that we had at the time. So we were jamming the nozzle of the robot down onto the clay, and it was spreading the clay, and we were losing a lot of detail. And so it was too coarse. But we were also using a digital technique where our meshes, as you might be able to see in a couple of the next slides, our meshes that we were cutting up to print weren't optimal for this type of printing, weren't fine enough, so we were getting really blunt resolution. And I'll see if there's nothing there. So here's an example. So when we started the exercise, we were working with these really low-res Delaunay triangulation models. So we were trying to work with carvers, and the carvers were like, don't make that line look so thick. We had to preserve their design intent, or else kind of thing. And then we were stuck with that, and we delivered the project with that really low resolution triangulation format from Grasshopper. We then jumped into another package and managed to, you won't see it because it's so fine, these are quad meshes, which is actually quite a feat technically, and that took us about 3 years to resolve. So we can confidently say that we can print or derive lines or carve to any level of detail, almost to molecular forms of detail with this new technique that we have. And so this is what it takes in order to not dumb down a lot of what our master carvers and weavers are wanting to achieve with their work. These are just kind of some blunt examples of some of the later models that we could start producing with this new technique of mesh smoothing that didn't lose much detail at all and didn't cause problems with our IT. And so this is a project that I worked on with New Zealand Māori Arts and Crafts Institute. I worked on it with that man there. He's a really well-known artist, Stacey Gordine. He works out of New Zealand Māori Arts and Crafts Institute. And when he came to me to see if we could build it or model it, it was only modelling to start. And that was the image that the New Zealand Māori Arts and Crafts Institute had won the project on. So quite low resolution in terms of understanding what materials and structures and those sorts of things. And then as we worked along, we managed to get a more elegant resolution in the end. It was some 4 years in the making, literally. And so I'll talk about this project now. Before I do that, I'll run this first video of the installation installed by a Black Hawk helicopter that came over from Tauranga. But it had two pieces to deliver to site, which are then assembled. So there's the sculpture there, obviously. That's the outer. And then the helicopter is going to retrieve the other part. And the reason why we used the Black Hawk is because a normal helicopter had a weight limit. And so we had to close the streets coming from Kilwell Industries in Rotorua, which is 3 or 4 kilometres away, to be able to fly the helicopter down the pathway of the road unencumbered, just to make sure it didn't have to fly higher over some of these hills and that sort of thing. There is the inner. And so we installed that just after COVID, or during COVID. And so this was, like I said, it was done with Te Puia and New Zealand Māori Arts and Crafts Institute in Rotorua. This is what Te Puia looked like 10 years ago. Since then, I see their website's been updated, and hope you edit this out, but there are more women in the picture. But there are, this is their Whakairo Rākau school, which they're very well known and famous for. New Zealand Māori Arts and Crafts Institute has the mandate to preserve the Māori arts and crafts into legislation in 1926, I think it was. The first intake into the school was in the mid-60s. And so from there, they've changed, they've grown, but they have a massive presence on site. So the project came out of a lot of the understanding of various Māori traditions around pattern, very deep understanding of tikanga and kaupapa Māori, mātauranga tuku iho, mātauranga āiwi, ahapu, mātauranga Māori, more general knowledge, but very much once I did summer schools and stuff with New Zealand Māori Arts and Crafts Institute as well. But as soon as we started the sculpture project, we realized that we had to bring a whole lot of thinking both ways. So from our side and also from the Māori Arts and Crafts Institute in terms of dealing with new technologies, materials and processes and that sort of thing. So I'll quickly take you through it. So here's the site down here. Te Puia is over here. If you've driven through Rotorua from Auckland, you generally come this way into town and then out. Very prominent site, a really problematic NZTA site where they had many, many fatalities at the T-junction there. So it was really welcomed that a new roundabout would be put in, and as part of that, they sent out a invitation for competition. It's really close to a very significant wāhi tapu of the people there, Te Pokea Te Ruahine, and it's the surface manifestation of Hoata, Te Pupu and Te Hoata, who were atua, wahine atua, female deities that came through from Hawaii to warm and to send through all the geothermal energy throughout this part of the country. And as you know, there's geothermal activity through these various stretches from Tongariro, Rotorua, off to White Island, back up and through parts of the north as well. So really significant site. This one here is a closer shot of it that is just part of the domain. So what you're seeing here is just a drone pic of the actual Pokea Te Ruahine. It's a very hot spot right next to the geyser in the background there. So this is what we were paying homage, this area is what we're paying homage to, as well as the main Te Puia geyser. The geyser they put for the competition, Stacey Gordine and some others put a camera down the geyser funnel, the geyser outlet, and noted that it had a double helical circulation when it blew its top. And it blows its top a couple of times a day. I've been there a couple of times. It's pretty dramatic and amazing. So part of their remit was to try and understand how that could be embedded in this sculpture. So a lot of initial studies, takarangi for one, a takarangi pattern, and we think these patterns are nice ornamental patterns. But through the project, we began to realise how through some of their configurations, especially with these whakaki nodules, holding each ring of the continuous spiral, and in three-dimensional format, they become highly structural. And so we started to realise what we were dealing with pretty early on. And when I say we, it was us at the university first when we started running our models and doing some structural investigations. Michael, no, I like to be on the tools, and so I didn't let any. Once we got excited about that, we were all in. But here's some of the ornamental elements or so-called ornamental elements that tell the story of the haerenga of these two atua. And so I won't go into the story. My brain is not wired like that. I'm more of a corn thresher or something. But incredibly deep thinking. And here's some of I'm rushing you through some of the early stage compositional bits and how the model would go together. So when we first started to work with the geometry and bring it together, I had the talents of Catherine Campbell-Hunt with me, an ex-student of mine, master student, who just slotted in, and we tried to deliver this very complicated structure. And when I say complicated, I'm saying that because of the double helical nature and the interlocking takarangi that we're now bringing from two-dimensional pattern into a three-dimensional configuration. So how do we deal with this doubly curving these curves, and how do we deal with the complex interpolation in order to move these whakaki around in order to understand how it would perform structurally. So just showing the whole configuration coming together. And so here is some of the stuff that my brain goes mushy on, but it's really, because what you see here is how we began to understand that the power of some of what we think are patterns and passive ornamentation in plain view have the mathematical seeds of generative design and generative systems. But the problem is we've never had tools that could understand them or rationalize them or bring them about. So this is some very, and I say very basic Grasshopper because it was. When I was learning Grasshopper, everybody knows how frustrating it is when you find its technical limits. It's around what it can do. But we moved it right through into keying and deflection and doing our own engineering structural calculations, because we had, on the one side, we had Opus. Don't know if anyone's from Opus, but Opus were asking us for information and saying it could never be done and all this kind of stuff. And you need horizontal struts and all that sort of thing. And so what we did, we just tried to figure it out ourselves, and we did it any which way we could. And so we had a goal in terms of our deflection that we asked them, we sort of hinted and didn't let the cat out of the bag, but asked them what deflection would be ideal, and then we used that information that we were able to glean from them without letting them know what we were doing. But we worked out that it could work within about 2 weeks of finishing the project, the actual digital model completely. It took Opus 5 months, and I was constantly calling them, and that probably should be edited out, but it was just because they didn't have the tools to understand it either. And so it was a real challenge to sort of move in both direction through some of these tools and to really understand what we were doing, because the last thing we wanted to do, and we had it in some of these submissions, contractor submissions with method statements, the contractors who we wanted to build it were saying, you can do this, but what you've got to do is straighten out all these curves and have lengths of 400 stainless steel welded, and then move to another straight of 4, and then it'll look similar. So we had to we went overseas. We went We went to Canada and we went to Philippe Yuan, who had a robotics lab at the time, and said to them, look, can you help us to build this? And they were like, what, stainless steel? And we were, at the time, we was like, yep, it's stainless steel. None of them could do it because of the high levels of chromium that it would require to combat A, corrosion, and B, just that structural strength it would need to be self-supporting. And so it would tear and crack and shatter, basically. But they, Philip Yuan had he had his own practice, really well known, but he, on the faculty at Tongji, he had a fleet of robots that he had waiting to do the work, but it couldn't be done. And also this advanced bending technologies said they couldn't do it, and yet they did, they did high-end stainless steel bumpers and for cars and with really tight radii. So down the road we have Kilwell, and those who we ended up working with. The reason for this is that one day we just shifted and said, well, why don't we just 3D print it in PLA, in bioplastic, and then carbon fiber, the exterior. So that I'm working with a supplier that already did that with fishing rods and small scale items in industry. We found a good partner. Still very risk adverse. People wanted us to lose complicated things, and we were both doing things on the fly. So they'd never done it before. They certainly never had 8 printers printing for, months and months, 24 hours a day, 7 days a week, breaking down, ordering parts, those sorts of things on some big deadlines. And so we were always, I was feeding files along, and then we're testing. At the time we had, and this is not very long ago, but we still had a maximum print bed height that was affordable of 600 mils in a raised 3D printer, 600 by 350 by 400. And so we had to fit all of those curves into that envelope in order to print each one. And then there was, it was then carbon fibered in the workshop there. So 10, 11 times stronger than steel with a 5-coat carbon fiber sock. And here are some of these are some of the images when I went to see it to try and pick up on defects and rough work. And, the supplier, the contractor, was really fed up. And so somehow that had dissipated down to their workforce. So everybody was fed up. And so they were doing some really shonky work. Whereas normally they do amazing work. So we had to, remedy a bit of that. If you go and see the sculpture now, I think they've remedied, 90% of that out. But very, very difficult project to build. And there's some of the earlier photographs of it. I've got a couple more projects, but I think you might start to get a feel for the way that we're working. We're trying to sort of open up the spectrum of design, not sort of adhere to a preset process or procedure. This project was called the Ngāpu Manawa E Waru, or Te Arawa. I don't know if there's any Te Arawa people here today. Very famous memorial. Back in the 1980s, it looked like to some people at the time that someone had backed into one of them accidentally and then took the other one as well and chucked it in their boot. So there were only 6 left. And so when I got involved with the project, and it was via New Zealand Māori Arts and Crafts as well, the first thing was like, we just need you to scan the ones that we have remaining because we want to bronze them, and we'll do some lost cast bronzing. And so it started off that way, but it ended up that we built a blending algorithm. I should really blank out part of it, but no, you won't figure it out. But we built an algorithm that breeds from parents. So we knew that we had 6 left, and they were all really, really different in terms of the features that they had. So every one of the 8 were quite unique, but some of them were self-similar. And so with this algorithm, we bred the most likely offspring of those ones that were lost from 3 selected parents through agreement. And so we were using these tools to try and, figure out a whakapapa approach, a way of having self-similarity, having siblings or relationships across a spectrum of discrete elements. Interconnection. We used it for other things as well, because I also used this script when I was in the north and we're printing a waka, and we had a meeting where these different waka practitioners came in, and I showed them a combination of a seagoing waka, a fishing waka, and a normal skiff. And we bred them. We sort of argued that the offspring would be a blend or have a whakapapa relationship. As long as all the, and this is just normal kind of non-technical knowledge, but as long as there were the same amount of faces and vertices and edges between each of the siblings, you could breed them. So with the waka project, we bred 5,000 in 15 minutes. So all of those technically could have been printed or used, I don't know how well performatively, but we were just starting to embark on how we rethink what we're doing with software and trying to imbue it with our own processes, our own, find our own inroads and our own settlements within these very hermetic, generally closed systems without having too much skill. We've also done scanning, and I'm getting to the last few lots of projects where we try to support what museums are doing, but we also support what whānau that don't want their information or their data out there in the custody of museums, in the custody of private users, or because they understand that the nature of digital tools, that it's near unstoppable to prevent people from dissipating your IP and altering it very rapidly. This is another project and I will have an extensive editing session because this one's quite confidential-ish, but it's only confidential-ish because it goes across borders. And so this one, we worked with the Canuck people in northern New Caledonia to scan a 6,500-year-old cave, which still had cave paintings. And so they wanted all of that archived and recorded. We had some we had some great tools to use, but within 6 months we noticed that the tools that we just used previously were no longer really up to the task if you're wanting to archive in perpetuity for a very long period of time. And so you have to go back intermittently. And so we were under the care of the two Canuck tribes in the north. Our most recent trip was just after the riots. A lot of tension in the air, but we were able to get in and go up to the far north and to the coastal areas and scan the caves under the guidance and guardianship of one particular iwi there. Really amazing experience. We've been in there for 3 or 4 other times, but the latest one has been the most amazing, most of all. And I'll just share the reason why. It's because when we removed a lot of foliage that was outside of the cave that had grown up for the last 40, 50 years, some massive tree trunks and bits and pieces, the light started coming in. The whānau, they were really concerned that they couldn't see a lot of the paintings anymore. So from our, so we kind of had a bit of a, we could relate to each other fairly well as Indigenous people, but and we know our tupuna don't do things just for the sake of it or just in an ad hoc way. And what we noticed was the different times that we went there. So we would have to travel down by boat. It would take about 1 hour each way, jump onto the reef, get across, and then start our work. But one morning we went in quite early, and the light actually, so went in early, and we were supposed to be gone by 1 or 2 o'clock because there was you had to be away from all the reefs and stuff by then. But we noticed the changing in light, and what we noticed is all of the paintings were facing, if you were to speak about it like a digital model, the centroid or the normal of a face was all they were all facing in one direction. And so they would all take the light at different times, but they would all take the light and they would reveal the paintings sequentially through the day. That's what we noticed. So after we talked to the iwi there, they were saying, well, it's for us, it's a wānanga space. It's teaching us at what times of the year, because we had turtles starting to appear at different times of day, and then we had tree structures, and they would appear and then disappear. And so we did a whole lot of analysis and modelling, and it's still ongoing, around the light access and how it could serve as a form of calendar or a centre of an observatory, and so being deliberate in terms of how things are placed and put into the cave. So I'll keep moving along. I'll show you this one more project and then we'll wrap up, and that is the Taurapa project that we did with a whole lot of researchers from Callaghan, from Robinson Institute, and they were trying to solve a problem of satellites tumbling in space. So in a vacuum environment, things don't stay stationary, they move and tumble. And what happens is any signals being passed from those satellite units fly out, in multi directions and become dissipated and lost. So we did a project around Taurapa that we looked at this idea that, well, this understanding that the vertical keel, so there's no keel under the boat, it's filigree, it's ornamentation, for want of a better word, creates drag and turbulence, which then stabilises the waka. This is public knowledge to an extent. It's been researched. Vic researchers have researched it. We've done a bit of stuff, a little bit of it with, and it's a dilemma I'll talk about when we wind out of the research. But we wanted to look how we could contribute to the Robinson satellite to stop, to either look at either the shape or the filigree patterns on the satellite to slow down or alleviate that rolling and twisting and tumbling. But just some of the tools that we used and some of the data that we crunched around that turbulence and drag, that those filigree patterns on the waka especially, and in relation to the height and the length of the waka, that kind of working with that type of data and understanding has started to drive us and reinforce the way that we work. And I kind of, luckily, Anthony talked to me about, a lot of this research remaining kind of under wraps or not. So, I'm not endorsing a free-for-all pulling apart of the Māori material world by any means. But what I am telling you is understanding that these things that we have been told about Māori things, the Māori arts, the Māori material culture through the colonial process, which we somewhat believe are being proven wrong. But they're being proven wrong only because now we have tools like computation. We have tools like we're able to do simulations. We didn't have those tools before. So we'll never be able to delve into the performative aspects of how these things work and how they perform. Okay, so I think I'll round it off there because there are other projects, but I think, and I have to apologise as well and talk to the editing team after, in terms of the, I'm just hoping that you have a feel for how the approach is, and that moving this approach into this new paradigm of robotics, where you no longer have a fixed machine dilemma. You don't have to purpose build a machine for 3D printing or clay printing or milling or carving or whatever else. The robots that we're like, and of course we used robots extensively for the last 10 or so years since we've had them, but it's now that I'm kind of got hold of the course, we might potentially take it somewhere different, and we might potentially really fully understand what it is we're dealing with, but through a different kind of lens that doesn't overlook. We're very much focused on picking up on all the details and all the opportunity in what we do with some of the research that we do. And so I guess round off before questions, just to say that, thank you for listening. And I hope you know, and my provocation to Anthony was that it was Indigenous robotics, but it's kind of absurd because, you know, we're still figuring it out. But our first port of call was to reboot and to revisit our old research and to understand our mindset and to understand the way that we were looking at materials and the way that we were seeing processes and machines and the way that we're seeing people involved with machines, and more importantly, how we see the Indigenous mind at work through all of, you know, all of our, especially our Māori students, because there is a little bit of a knack to it, especially around tapu. And if I can mention Raharuhi Rukupo, you know, Lazarus Rukupo, he managed to do what we can do now. You know, the building tolerances on his wharenui, and I say it every time I talk about the wharenui, Te Hauki Tūranga, are equivalent to building tolerances today, probably maybe even better, but he had 16 to 18 other carvers. But they were able to replicate to these fine tolerances, and we've had lasers through the wharenui and all of that sort of thing on the permission of whānau. We've seen how exact each one is that you cannot tell which author did each one. But the role of tapu in regulating the flow of ideas, of regulating how we use machines and how we control and understand both the technical limits and other undescribable limits of it are all there that have been left to us by our tupuna matua. So I'll leave it at that, and I'll await some questions, hopefully. Good to see a lot of people, everybody here today. Thank you for coming. And mihi atu ana, kia tātou katoa. Tēnā rā tātou.